Okay, yesterday we started really working on the skill of factoring polynomials. Factoring is where you try to take a polynomial and break it down into what could multiply to equal that polynomial. Okay? We did a lot of the difference of two squares yesterday. Okay? So, for instance, if you have 4x squared minus 9, those are both perfect squares. So what would my two factors be? Anybody? 2x minus 3 and 2x plus 3. Right? That was some of the stuff we did yesterday, the difference of two squares. Today, we're moving up in the world. Okay? We're going to work on the sums and differences of perfect cubes. Sums and differences of perfect cubes. So at the top of page 5, I would actually write both of these rules out so you can reference those rules as you work through some of these examples. You will not have to memorize these rules. Just know how to use them. You will not have to memorize the rules, just know how to use them. So I would write them down at the top of your page, and that way you can reference them as you do a couple. One thing that's typically handy to know when you're working with sums and differences of perfect cubes is what numbers are perfect cubes, just like you knew what numbers were perfect squares. Some of your perfect cube numbers would be 1, 8, because 2 times 2 times 2 makes 8, 27, 64, 125. At least knowing those first 5 are pretty handy. Okay, again, that's just 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5 times 5 times 5. Those are your perfect cubes. It's kind of helpful to know some of those. If you get a larger number than this, and you don't know if it's a perfect cube, on your calculator, you should try to take the cube root of that number. Okay? You should try to take the cube root of that number if you don't know if it is a perfect cube. Every calculator is different as to where that button is. I probably have to help you individually if you don't know how to do that on your calculator. The other thing you could do, if you don't know where the cube root button is you could raise that number to what power? 1/3. Raising something to the 1/3 power is the same thing as finding the cube root of that number. So if you can't find the cube root function on your calculator, you could instead just raise it to the 1/3 power to see if it is a perfect cube. Any questions on that? Okay, so now let's get into how do we use these rules for the sums and differences of cubes. I guess, actually, before I do an example, let me show you why what you might think is true is not. Some people think, oh, well, that's just going to be a plus b cubed. That doesn't work, unfortunately. It is not true. The reason it's not true is because if I take a plus b times itself 3 times, I would end up with some weird terms in there, some a squared b's and so on, right? A squared plus ab plus ab plus b squared, then I got to take that answer times another a plus b, and you end up with just a bunch of, it's kind of ugly, okay? So anyway, my point is, this does not equal that. You got to use the rules that are given. Right? So what do those problems look like? Well, I'll do an example here for you. 8x squared cubed, 8x cubed, I'll go plus 125. Okay, 8x cubed plus 125. We're going to factor that. Well, first of all, I need to recognize that these things are both perfect cubes. These are both perfect cubes. Because 8x cubed is the same thing as 2x times 2x times 2x. Right? 2x times 2x times 2x is equivalent to 8x cubed. And 125 is really what cubed? 5. So you need to recognize that 8x cubed is a perfect cube and 125 is a perfect cube. You need to recognize that right away. I think it's helpful to write this step out. Some of you won't think it's necessary, which is fine. But if you're struggling, I really think it's important to write this step out. Because once you write this step out, all you got to do is look at this rule and follow it. And here's how you follow that rule. Right now, I have something cubed plus something cubed. So I'm going to follow this rule right here. It's the sum of two perfect cubes. That's what I have. I have the sum of two perfect cubes. So all I'm going to do is I'm going to use these factors here to write my answer. But instead of using an A and a B, I'll be using a 2x and a 5. So it's pretty simple. A plus B, for me, 2x plus 5. A squared, 2x times 2x is 4x squared. Minus the product of AB. So minus the product of those two things. 10x. 2x times 5 is 10x. Plus B squared. So plus that times itself. And you're done. That's it.
Do you have to distribute?
If you distribute this back together, what should it equal? That'd be a way to check your answer. But your directions are just to factor. And that's what I've done. I took this and I factored it down to its two factors. You can't go any further. You'll be done right after you use the sum and difference rule. Okay?
Okay.
What are your thoughts? Questions?
What if it's not a perfect cube?
If it's not a perfect cube, you may need to pull out a greatest common factor first, and then after doing that, what's left might be perfect cubes. Okay? I think all the problems on this worksheet do at least require you to use either the difference or sum of perfect cubes. Okay? Good questions. What other questions do you see maybe you running into? I try to avoid negatives. So in other words, if somebody gave me this problem and told me to factor this, I don't want to mess with a negative x cubed. I would probably rewrite this in this order. Right? And then all I'm going to do is use this rule right here. Because 1 is a perfect cube, and obviously this is a perfect cube. So I'm just going to follow this rule right here. So my answer is simply 1 minus x. 1 squared is 1, plus the product of 1 and x. So plus 1x plus x squared. Okay? You can still get to your answer by using this rule, but then you're using a negative x within the rule, and people tend to screw up when they use negatives. So I would actually rewrite it this way and use the difference rule instead of the sum rule. That makes some sense? Okay. I think after doing about 5, 6, 7 of these, you probably got the hang of it. If this is really easy for you, try the ones on the back side of the worksheet. Try the hard ones. Okay? You don't need to do all of them. Do as many as you can. If you struggle, just or if you're worried you're going to struggle, start at the top of the worksheet. If you think like you know it pretty quick, try to go to the really difficult ones on the back. I'm going to give you about 15 minutes just to work on the sum and differences of cubes, and then I'll move on to the next step. Okay, go ahead.